Quantum chromodynamics. Quantum chromodynamics is the branch of physics that describes the fundamental interactions between the smallest particles known as quarks and gluons, which are the building blocks of protons, neutrons, and other particles in the nucleus of an atom. In simple terms, quantum chromodynamics helps us understand the strong force, one of the four fundamental forces of nature, and how it holds together the particles that make up matter. To start with, it's important to know that all matter in the universe is made up of atoms. Atoms consist of a nucleus, which contains protons and neutrons, and electrons that orbit around this nucleus. However, if we zoom in on the protons and neutrons themselves, we find they are not the smallest building blocks. Protons and neutrons are made of even smaller particles called quarks. Quarks are held together by another particle called a gluon. Now, the main goal of quantum chromodynamics is to explain how quarks and gluons interact. The term chromodynamics comes from the word chroma, which means color. However, this color in quantum chromodynamics does not refer to the colors we see with our eyes. Instead, it refers to a property of quarks similar to electric charge in electromagnetism. Quarks come in three colors: red, green, and blue. Gluons are responsible for exchanging these colors between quarks, effectively holding them together. The idea is that, just as positive and negative electric charges attract in electromagnetism, the different color charges in quarks attract each other in quantum chromodynamics. Quarks cannot exist in isolation, they are always found together in groups. The most common groups of quarks are pairs of three quarks, which make up protons and neutrons, and pairs of a quark and an antiquark, which make up particles called mesons. Quantum chromodynamics explains why quarks are confined within these groups and why we can never see them on their own. The force that holds quarks together, mediated by gluons, becomes stronger the farther apart the quarks get. This is the opposite of how forces like gravity or electromagnetism work, where the force gets weaker with distance. Because of this property, quarks are permanently bound together, a phenomenon called confinement.